Okay, so hi everyone. I'm Avishai. I'm from Wix. One of the, let's say, Clojure sympathizers in Wix. We're actually a Scala Java shop, kind of. So we don't do a lot of Clojure programming. There are some die-hard Clojure fans in Wix. I'm one of them. I did a couple of projects in Clojure in previous companies, unfortunately not many in Wix. And we write in Scala, which is kind of a bummer for me, I have to say. Actually, I did one project in Wix in Clojure. Yeah, in a hackathon. Yeah, because they wouldn't let me write Clojure anywhere else. Who's using COBOL? Anyone using COBOL? D? Basic? No? Oh, you're using BASIC?
Used.
Oh, used. Okay. I thought you were a pervert, but never mind. Okay, so anyone using Lisp? Oh, a couple of people. Okay. When was Lisp created? 90 what?
57.
57, almost, you're close. 58, yeah, that's it. 1958. So all the languages that I've mentioned are pretty old. They're like very old. COBOL is from around the same time. BASIC is from the 80s, I think, or the end of the 70s. COBOL is from the 70s, I think, or maybe even the 60s. Don't remember exactly. But Lisp is one of the oldest languages and the only one still in use. And I find it very interesting that only one language has survived, for 50 years, and people still use it. That actually, what? Sorry. Oh, in Netherlands, yeah. But that's actually from the 70s.
No, Netherlands is not old.
Is that so old?
83.
Yeah. So I find it very curious. I mean, there has to be something fundamentally good about the language if it survives for so long and for so many technologies. Think about this. We didn't even have mainframes when Lisp was invented, and no one ever uses mainframes anymore. So, this is mind-blowing. And Clojure is kind of a modern variant of Lisp. And it's not exactly the same Lisp that we all know and love, but I think it's actually more awesome than traditional Lisp. What I'm going to show now is I'm going to try and show you a little bit about the mindset of a Clojure programmer. Because Clojure programmers kind of have a very different approach to programming because the language kind of allows it and makes it easy. So Clojure programming is much more iterative and much more interactive than you would usually think. And the reason for that is something called the REPL. So you've seen before that when you program in Clojure, you have instant evaluation kind of thing. And this is from something called the REPL. So I'm going to open the REPL here. This is from iClojure, not that it matters. I can do it from here, doesn't matter. And the REPL is basically a command line interface that allows me to just input commands. Sorry, 1 second. I'll open it in a different place. Sorry about that. Whatever. Yeah, because I'm in a Lengen project. Okay. So this is the REPL, and I can just type in commands or whatever I want and just evaluate it and get, instantly the feedback. And that's not very impressive because Scala has it, even Java 9 has it. I mean, everyone has this kind of interactive interface, not very important. The really interesting part about the Clojure REPL is it's actually wired for remote operation. So it opens a port, and you can connect to that port and run whatever you want. You can evaluate remotely whatever you want. So you can have a local REPL, you can have a REPL running on a server, maybe in production even, and you can just inject code to it from your IDE, or usually people mostly use Emacs, but you can do it from Sublime, whatever editor you use, and just evaluate stuff. So I have a REPL running here in cursive. This is IntelliJ. And I can just do the same thing here. And yeah, it's not very impressive. It's kind of cool, but not very interesting. But I can also do it from here. So I can do this from the IDE. And yeah, weird. Why do I get this? Because I didn't define a namespace. So voila. Now I evaluated the namespace here. This is like package in Java or whatever. And now I can just evaluate code on the fly and do whatever I want. How does that impact the mindset of a Clojure programmer? So a Clojure programmer kind of builds everything from bottom to the top. So usually when you design a program, you think about, okay, this program is supposed to do something, and for this I need this other thing, and maybe I have a diagram, and I have like lots of blocks, and I give that diagram to someone maybe, and then I start implementing all the blocks. In Clojure, it doesn't work this way. We just kind of start somewhere in the middle, and then we find out what we need, and we kind of implement that, and we see what happens, and we play around with it, and we look at the function, and it's like, oh, I like that function. And it's like, oh, wait, I don't like this function. I mean, the output is just, I don't like the way like the output is. Maybe I want to change the data structure. So I just do it on the fly, and I kind of work my way until I get a program. And this kind of reminds me of a methodology that we use a lot in Wix, which is test-driven design, TDD, which is all about instant feedback. And the way we get this instant feedback in Scala is we use test. We write a test, we run it, we implement the code, we run it again, we see it fail, we implement more code until finally we have a test that is running. But in Clojure, you don't have to do that because you can actually see what's going on. So I'm going to implement a solution to a problem. And it's kind of a problem that is statistical in nature. It's the bin packing problem. And anyone heard of the bin packing problem? A couple of people. So basically, think about maybe you have a shipping container and you have to pack a lot of bins into that container. And the containers have a specific size, and the bins comes in various sizes. Some of them are pretty big, some of them are pretty small, but you want to store as many bins as you can in the containers. So if you fill up a container too much, then maybe you won't have space for another large bin, then you have to put it in another place, and it won't be optimal. You'll always have some space left. So we want to find some algorithm to do that for us. So let's start by running a function. Let's call it pack bin, because of course we're going to pack one bin when we start. It's going to receive a containers, a list of containers, and the bin, of course. What would be the form of this? Like, what would be the data structure for a container or a bin? So in Clojure, usually we just use a generic map for everything. We try not to make everything too complicated. We don't want to use classes, types, whatever that stuff is. We just use something like, so let's say containers would be something like a list of, let's say, maps. Let's say, what is the size of this container? Let's say 1,000. And what is the contents of this container? Just an empty list for now. And a bin, for example, would be, again, it would be a map. Let's say the size of the bin, this specific bin is, let's say, 23, and it has an ID. Because, I don't know, probably we should add an ID for the containers as well. Okay, that's nice. Maybe we also want containers to be a map. We want to refer to them by ID. Because if we want to find a specific container, it makes sense that it's easy that would be easy to do so. So let's replace that, and instead we would have an ID. ID, and that ID would refer to. Now we have a problem because those two function calls for UID, they will return different IDs. So I have to replace them with a variable. But in Clojure, we don't really have variables because it's kind of an immutable language. So instead, we have lexical scoping. We have something called let. Okay? So the way this works, is I bind some expression to a name. And it looks really, really weird at first. But it's just like defining a variable, except that this variable is bounded in scope. Okay?
It actually has extracted variable in cursive.
Yes, I know. But like, you can pretend that this is Emacs for now. Anyway, but this is the point. Like, this is the basic data structure that I'm using, and I'm going to work my way through from here. So to pack a bin, we need to put it in a container. What do we need to do first? We need to select a container, right? So let's do, say, candidate or selected container. Let's call it selected container. And we might have some function to select this container. I don't know how we're going to select it, but Obviously, we're going to need to give it the containers and the bin, of course. And having selected the container, we can then just put it in. Okay, what happens if we don't find a container? Okay, what would our function return then? Select container. What would make sense?
Same set of containers?
Well, select container should return one specific container or the ID of a container. So if we don't find a good container, what would you do in a different language?
Optional.
Option or something like that. Maybe, yeah. So in Clojure, we have a methodology called null punning. Null is actually a value in Clojure, and we use it everywhere. It signifies that nothing exists, so we haven't found anything. It's like 0 in numbers, basically. So it's okay to get null. But how do we deal with null? Basically, we have something called when, which is kind of like the option monad or optional in Java. Just ignores stuff that are nil, doesn't execute the block. So I can say when selected container, meaning when selected container is not null. Then I want to update my container map, containers map, and inside the containers for the container ID that I have, which is the ID of selected container, I want to do something to its contents. What do I want to do there? So update takes some function. See, tells me what the arguments are. It takes some function and it applies it to the value of this map, which in this case I want to conjoin. Okay, it's like concatenate. I want to add to the list of bins to the contents of the of this container. I want to add this bin. So conjoin bin, and that's basically it. Now I have this select container. How are we going to select the container? So let's write this function, and it's going to receive containers, and of course a bin. So how are we going to select a container? First thing we need to do is to make sure that we have a container with enough space. Okay? So we want to iterate on all the containers, find a container that has enough space, and maybe take the first one. I don't know if we care more than that. So that makes sense. So first thing we need to do is, because this is a map and we all care about the values, we don't care about the IDs at the moment, so let's take vals of containers. Okay, cool. Now we have a list of containers, and we're going to filter on them. And probably we want to filter on something like, we need to give it some function, so let's try something like bin with, container with space. Let's assume we have this function. This is basically what we want to do. Of course, container with space needs, space for a bin, so it needs some argument for a bin. So if we wrote this function now, it would be something like container with space. It of course needs a bin and of course a container. Okay, doesn't matter how we do it for now. So here we can use partial, because filter should receive a function that gets only one argument, which is a container. Okay, so this is why in this function I have bin as a first argument, so I can add bin to it as a partially applied function, and now it receives only one argument, which is a container, so filter will now work. And now that I've filtered this, okay, so I could just do first. Just pick the first one. That makes sense. Does this work? Well, first of all, we haven't implemented container with space. Okay, let's stop it for now. Just stay true. Okay, probably won't work. How will this behave? I don't know yet, because I haven't actually run anything yet, so I can try now. Let's see container with space. Container with space, let's give it a bin, or a test bin, and let's give it container, first container from the list, all the same, so it doesn't matter, and run it. Aha! What do we have here? Unable to resolve symbol. Why? Because we haven't evaluated any of the function definitions, have we? So we can just do that. Let's mark all of them and send them to the REPL. Bam. Okay, now we can do this. Sorry, what did I do? Oh, bin, I haven't evaluated those as well. Cool.
You missed an S.
I missed something somewhere. Yeah, this. Yeah, now it's fine. Okay.
No, the last line is containers, not container.
Oh, sorry? Yeah, that too. Thank you. So this, there's a UID. I forgot to import. I'm not in the correct namespace. Sorry about that. I should be in this namespace. Cool. Cool. Okay. Awesome. Good. Okay, so let's run this, and we get true, of course, because we stopped it. That's very surprising. Let's run a select container and see if this works and what it will return. So containers and bin. Okay, this looks good. Right? But apparently, yeah, it's selected container, and let's see if our implementation of pack bin actually does something. It should pack it into a bin, although it's not. So pack bin containers, bin. Cool. So we have in the context, we pack the bin. Okay? So currently, our algorithm is faulty because container with space always returns true, so we need to improve this, of course. So instead of this, we might want maybe take a look at the space. So we can compare the size, the space available in the container with the size of the bin and see if it's enough. So this is a function. Okay, it's in many languages this is an operator. Here it's a function, greater than. So if the container, let's say container space is greater than the size of the bin, yeah. So that would be like this. Then it should be okay. Now what is container space? We don't have this function yet. We can just write it. We pretty much know what it does. So container space would take a container and return how much space is available. How do we compute how much space is available? The size of the container minus the contents. Exactly, sum of the contents. So minus what would be the size of the container? Size container. And of course, we need to sum.
Reduce plus.
Yeah. Sum the map of size of the bins. Right? Where are the bins? Anyone know what the bins are? Contents, exactly. In the contents of the container. Oh, this is ugly. This is ugly, right? Thank God that we don't have to do this in Clojure, because this would be ugly, right? So in Clojure, we have something very cool called destructuring. If I have a map, I can just pattern match it into something like this. I can say container size is the size, and contents would be the contents. And Clojure automatically destructures my map according to the specification that I've given it. So now I can just do this, which looks much nicer. So all of the let bindings, okay, all of the let expressions and all the function expressions allow for this type of destructuring for maps, for vectors, for everything. And this is a very cool feature. So now we can evaluate this, and we can test our function again. Okay, looks good. Okay, we might want to test select container. Okay, select container appears to be working. Let's see what happens if it can't find let's say test the corner case, for example, one where it won't be able to select a container. So instead of this bin that we used that had a size 23, let's give it a different bin. It's very easy because it's just a map. So let's give it a bin with size, okay, this should not work. Aha, that's weird, right? So what is the bug? Anyone? Maybe we want to try and check container space. So container space, okay, we get the container size. So give it one container. So first container, and let's give it a weird bin. Sorry, we don't need it. We don't need this. Null pointer exception. Where do we get null pointer exception? So you would see that we're missing a stack trace here. But actually we can get it from the REPL. We just click here and voila. Now we have a stack trace and we know exactly where this happened. This happened in line 5. So what's the problem here? Anybody want to take a guess?
If you don't have contents.
What, sorry?
If you don't have contents.
If I don't have contents, then it will be nil.
Yeah.
What's the problem with nil? We'll not have any contents.
What do you do with sum?
What do I do with what?
What is the sum function?
Just 0, I guess. It's a reduced plus.
It won't return a 0 size.
It won't return a 0 size. Why not?
Reduce plus on nil.
Sorry?
Map size.
Actually, you can. But this should be easy to fix, right? Remember, we have when. So when contents, all just return 0. But we don't have to do this. So is sum the problem? What do you think? We can just check, right? Again, we have the REPL, so we can just do sum. We think that the problem is summing on nil, correct? Okay? No, sum on nil is just 0.
Give it a default.
So maybe
0 when you do a size.
yeah. So maybe this is the problem: size of contents, which was just this. Again, 0. This is not the problem.
The reduction, the minus.
The minus? Minus container size?
Container size, something minus nil.
Well, it's 0. It's 0. It's not that.
0?
Yep. So, any ideas? Someone?
Have you evaluated all the namespace?
Oh, that's a very good question. Have I evaluated? So now I'm evaluating everything, and again, I get this. Select container returns nil, as it should. Okay? If select container returns nil, and container space is a problem. Containers, blah, blah, blah. So remember, containers is a map. It's not a vector. I should actually do this. Okay? So different data type. This is why this happens. There's a very, very easy way to avoid this kind of problem. In Clojure, because it's a dynamic language, we actually have validations you can attach to functions. Okay, it's called pre and post. You can attach validation on arguments and on the return values. I'm not going to show it here, but just know that this exists. It's a very nice feature. If you're interested in that, read about contract programming. It's this kind of methodology. Anyway, so moving on. Now we have a very naive implementation of bin packing. And of course, we're not interested in packing just a single bin, right? We care about packing a lot of bins. So now we need to extend this, and we need to do something like pack bins. So we need to pack a lot of bins into many containers. Okay? If we've already solved this problem for one bin, how do we progress and solve it for many bins? Any ideas? Map is no, won't work. Recursion would work, yes. Other ideas that don't involve recursion? Reduce. That is correct. Okay, so we want to reduce. And reduce gets a function, an initial value, and of course some collection. Our collection in this case would be bins. What would be the initial value? Our containers, the containers that we got. And now we need to have this some function that would pack everything. So because we already solved this problem for one bin, we can maybe do this, right? Okay, but remember, what would pack bin return if it didn't successfully pack the bins? It would return nil. So what would happen in reduce? When one argument is nil?
Zero the state of nil.
Probably. So let's try it. Let's evaluate this and try this new function that we have. Of course, we want to create some bins. So I've already created functions that generate bins because I'm kind of lazy and I don't want to generate them again and again. So let me go to the function and get it. So I have generate containers, I have generate bins, I can copy them here. Okay, so this function basically generates a bunch of containers, and this generates a bunch of bins. So now I can replace this with generate containers. I want to generate, let's say, 10 containers with size 1000. Okay, and now I want to generate a bunch of bins. Generate bins. Let's say I want to generate 100 bins with the random sizes from 0 to 15. Okay, that makes sense. Now let's check our function. Pack bins, and I'm going to pack the bins into containers. Okay, and I'm going to run it, and boom, unable to resolve symbols. Oh yeah, I forgot to evaluate this again. Okay. Cool. And evaluate this. Okay. This kind of works. Okay, I've packed. You can see that in contents, I've packed the bins. Now you would notice that because our algorithm is kind of shitty, and he always selects the first container, everything was packed in the first container. Right? That makes sense. What happens if we try to pack more bins? Let's try 500 bins. Okay. Now we've actually utilized more containers, and so on, so on, so on. But okay, we have a working implementation. Maybe it's time to write a test, right? So let's write a test for this implementation. So the way we write tests here is we have something called def test. This defines a test. We give it a name, bin pack, bin packing, whatever. We can write some nice description, bin pack a single bin into a container. Okay, that's nice. And now we can write assertions. So this is the basic assertion in the normal testing library of Clojure. Okay, cool. I want something to be equal to something. Okay, so let's bin pack bin, and we want to generate a bunch of containers for the test. So def containers, and I can generate containers. Sorry, I need to require this namespace, meetup demo, bin packing, cool. Okay, so generate containers that generate 10 containers of size 1000. And now we're going to generate a bunch of bins. Bin, generate bins. Actually, we don't need this. So one bin of size 10, ID, EUID, whatever. Cool. So we're going to pack this. Okay, and what kind of assertion do we want it to do? Okay, do we care about equality in this case? No, right? We care that the contents has at least one bin, because this was previously empty, and now it should have the bin that we want to pack inside. Okay, so what do we want to do? We want to extract the contents of this, and we want to say that the size of this, or the count, is larger, or we can say contains that the contents contain some bin. Okay, actually in Clojure it would be something like this. Some. It's going to be a little ugly. Bin. Okay, and I can run the test. And sorry, it was already referred to. Blah 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 blah. Bit of renaming here. Okay, so I have a built-in integration in IntelliJ of the whole testing framework. So when I run this, it automatically inputs the results of the test, so I can see exactly what's going on. So it tells me, oh, your test has failed. I've expected this, and instead I've gotten this. Okay? So in this case, my assertion is wrong. Should be something like this. Now I can run it again. And it tells me, okay, you have gotten nil. You've expected to get a bin with size 23 and this ID, and instead you've got nil. Your bin packing has failed. Okay? So yeah, we've got a problem here. Our tests fail. Any ideas why? Remember, again, this is a pack bin. Exactly, it's a hash map. It returns containers. So again, I need to do vals, and I need to check the contents. So vals, yes. Okay, cool. And again, this is very ugly. This is very hard to work with this. So how about I just surround it in let? So bin, vals, pack bins, test containers, and test bin. And I can just move this into here, and I can do this. And now I can just check everything. Also, I can extract the bins that I want and do this. So bin should be equal to sum bin and the contents of the containers. Okay.
Is it test bin or a regular
Sorry?
bin?
Don't understand. Oh yeah, you're right. This should be test bin. And actually now, because I have let already, I can just move this here. I can move this here. Because let, again, and just to remind you again, it's lexical scoping. So it overrides everything. And I can just do this now, and it will be much better. Bin is of size 10, and ID, don't care about the ID really, but fine. And it's much nicer now, and I can remove this. Okay, cool. Map later contains in number of forms. And, sorry? Size of the bin, where is it? This one? Oh yeah, thank you. Cool. Okay, so I've got nil again. Expect nil and, sorry, where is it? Test, blah, blah, blah. Okay, so you get the idea. And of course, I can also do debug and do breakpoints and everything you're used to. But this is kind of how we work. We write some code, we iterate on it, we express whatever we want to see. If we want to see like the data structures and what kind of output our functions give us. And this is important because this is dynamic language. So often we might change the maps, or we might change the return values, or even the return types. So it's very important that we can run it and see what's returning and what is the semantic of our function. And this is very important because often you don't know. The basic assumption when you do design is that you know upfront the way your functions are going to behave. And often when you program, you have no idea. It's kind of it's more like drawing really than designing often, especially when you're working with low-level functions.
You gotta map the contents of the containers.
Yes. So last thing I'm going to show you how we do integration testing. So in this case, I have a very simple web app. Doesn't do much, just say hello world, and I've got connection to Redis, which just pings to Redis. But what I actually want to show you is the tests, how to test. So this is the tests. So I have one test suite that does complete integration testing. This is an HTTP client issuing a call to localhost and everything, and checks everything like it should. I'm going to run it. Sorry, 1 second. And I've got one error. If you can see what's going on here, it tells me that I've expected the hello world capitalized and with an exclamation mark, and my code was hello world without this. Okay, so my body is wrong. I can go and fix it now. But I can see all of this from the REPL, and you would notice that the integration tests were very, very fast. It was a split second. And if you look at the fixture here, this thing here, this is what wraps the test suite. So essentially, for every run, I boot up a Redis server and my Jetty server, which is the HTTP server. And this is all up in like split second. So usually when you do something like this in Scala, you have to wait because you compile your code, this takes a while, then you have to start stuff like Spring and whatever, it takes more time. It's not uncommon to have a test run take about, even half a minute. And here it's much less than a second. Last time I timed this was like 200 milliseconds for a test run, which is nothing. And why? Because the REPL is already loaded, so we don't pay the overhead of starting everything up. We just inject our code into the REPL and let it run. But actually, we don't really need integration tests because in Clojure, everything is a function, including our handler. So the handler that we defined here is just a function which receives a request object. And the request object in Clojure is actually just a map. So we can generate it easily, and we can run this test suite, which is much more efficient and easier because all it does is it sends to the handler function a request that we generate. And that's it. And that's enough. If we don't care about Jetty, this is more than enough to test our application when you don't need to run anything. And this works even faster. Okay? Because really it's just kind of an acceptance test. We don't even need a web server. So what happens when we have state? And maybe we want to play around with our server. So when you have state, when you have a database, or maybe you store some state in memory, or maybe you change a program on the fly and you still have stuff in memory, and you might want to reset it without exiting from the REPL. So there's a nice pattern called the reloaded pattern, which looks kind of like this. I'm going to load this namespace now. And basically what I defined here, don't care about the weird syntax and everything. Basically I defined some lifecycle, which has a start and stop methods. And on start, I'm going to start Redis, and I'm going to start the HTTP server. And when I say stop, it's going to destroy Redis, and it's going to destroy this Jetty server. And then I can just do something like that. I can tell it go. It will load everything. And now I have a complete system running, and I can just, let's see if it works. Localhost 8080, Redis, sorry, hello world this should be. And yeah, I got hello world, okay? So this is just an HTTP call. And I can play around with the server, and I can do some stuff, maybe save some stuff in the database. And when I've had enough, or maybe I want to reboot the whole thing and clear the state, I can just do this. I can tell it to stop, and the server is down. If I do this, now it will say connection refused, or I can start it up again if I want. Sorry. And hello world, of course, or I can clear it. Clear basically stops, throws away my entire server, and then when I do go or init, it will load it up again. This is called the reloaded pattern. And when you're developing interactively stuff, and you might have some state from the games that you've made along the way, this is very, very helpful. And actually, you can do all of your programming and iterate very, very quickly without restarting the REPL, except for maybe when you have new dependencies and you have to fetch them from Maven Central or something like that. But I've actually written entire servers without rebooting the REPL even once, which is pretty amazing. And it's much faster than any type of programming that I've done anywhere. And I find that it liberates me from the need to do a lot of upfront design. And it also creates this kind of evolutionary feel where you kind of grow your software organically. So I'm kind of out of time. So if you have any questions, now is a good time. And you can also catch me later around. I'm going to be with the beer. So find the guy with the beer, basically. Any questions? Cool. So thank you.